Hello everyone, welcome to our channel. Hello everyone, this is Dr.Nazma and welcome back to our channel. In this video, we are going to talk about mole concept part 2. So in part 1 of mole concept, we discussed the basic introduction, as in we understood what's meant by the concept of mole, followed by understanding the value of mole in terms of number, liters and also mass, right? So today we'll be working on understanding the concept of atomic mass, followed by calculating molecular mass of different elements. By the way, this video is most helpful for the students of class 9, class 10 and also class 11. If you are lacking at your basics but still you are in class 12, this video is going to be of some use. Done? Let's get started in a fresh page without any more delay. So what do you think is atomic mass? Atomic mass is nothing but mass of an atom. But then what determines mass of an atom? If you slightly go back to your class 9 and class 10 level of study and observe the atomic structure, an atom is supposed to consist of subatomic particles, and major subatomic particles are electron, proton and neutron. And electron is negative, proton is positive, whereas neutron is nil or zero charge particle, right? And if you observe their mass, proton and neutron have considerable mass, which is 1.007 and 1.008 atomic mass units respectively. By the way, the masses that I spelled just now are approximated values. They are rounded up values, cool? And the mass of electron is very less, which is 0.0005 atomic mass units. When you compare mass of electron to that of proton and neutron, electron's mass is very less. We can say it as negligible. Because electron's mass is negligible, we don't consider electron's mass while you calculate mass of an atom. Say for example, I have an atom which is consisting of maybe 2 electrons, 2 protons and 2 neutrons. Fine? Electrons, protons and neutrons. So if I have to calculate mass of this atom, I will not consider these electrons to calculate the mass. I'll only consider the mass of protons and neutrons. Why? Because electrons are very negligibly massed when you compare them to that of proton and neutron. So atomic mass literally is nothing but the mass of protons and neutrons present in one particular atom. Fine? So now, how many protons and neutrons are there in one particular atom? It is specific. Which atom are you talking about? Say for example, you're talking about hydrogen. Hydrogen has 1 electron, it has 1 proton and it has 0 neutrons. And similarly, if you talk about helium or lithium, beryllium, boron, the number of electrons, protons, neutrons depend upon the atom that we are talking about. So now you don't need to bother about number of electrons because you're not anyways counting them while you calculate atomic mass. But you need to bother about number of protons and number of neutrons. Why? So in spite of remembering proton count and neutron count separately, it is better remember the atomic mass itself. I'll give you a few important elements and their atomic masses that will be very frequently used in the syllabus so that you can memorize them easily. Let's get started with hydrogen itself. So you're talking about hydrogen's atomic mass. As said before, hydrogen has 1 proton and 0 neutrons. So its mass, the atomic mass, one hydrogen atom's mass is approximately 1 atomic mass unit. In fact, it is 1.004 atomic mass units, but we can round up the values to the closest figure. Fine. And then the other important one is atomic mass of nitrogen. Atomic mass of one nitrogen atom is 7 atomic mass units. And when you talk about another atom, oxygen's atomic mass is 16 atomic mass units. And then for sodium it is 23 atomic mass units. And then for magnesium, the mass is gonna be 24 atomic mass units. And carbon, 12. And also aluminum is important for your syllabus, 27 atomic mass units. Sulfur, 32. Phosphorus, 31. So anything else that's missing? I guess that's it. So whatever has been listed here, these elements are like very much used in the level of class 10 and class 11. So without knowing atomic mass of these elements which are written on the screen, the things do not work. So somehow you got to learn it, somehow you got to memorize it. Okay, done. So there's one error here. Atomic mass of nitrogen is not 7, it's 14. Atomic number of nitrogen is 7. I'm so sorry for that, right? So let's go on now. So the atomic mass concept is this. Atomic mass is mass of atom. Literally, it is nothing but the mass of protons and neutrons present in that particular atom. And we already know that atoms are not stable as they are, correct? And these atoms will form molecules by clubbing with each other, and these molecules are stable units. So what about the mass of a molecule? If I call mass of an atom as atomic mass, what would I call mass of a molecule as? Mass of a molecule is nothing but molecular mass, right? So molecular mass. Then how to calculate molecular mass? Let's take example of some molecules first, and then let us see how to calculate the molecular mass. Say, let's take hydrogen molecule. Hydrogen molecule does exist as H2. It is a diatomic molecule, correct? So H2, observe this and tell me, how many hydrogen atoms do you have here? Literally, there are 2 hydrogen atoms. The subscript that you see here signifies the number of atoms in a molecule, right? If I talk about O2, 2 oxygen atoms are making 1 molecule. If I'm talking about ozone O3, how many oxygen atoms are here? 3 oxygen atoms here, right? That means 1 hydrogen molecule is made up of 2 hydrogen atoms. And what is the mass of each hydrogen atom? 1 hydrogen atom's mass is 1 gram. 1 atomic mass unit. And we are talking about 2 hydrogen atoms making a molecule. So the molecular mass of hydrogen will be the mass of both the hydrogen atoms present here. Are you following me? Yes, right? In case you have any doubts, please don't hesitate asking me the doubts in the comment section. Fine. So you have 2 hydrogen atoms. The total mass of H2 is gonna be 1 into 2. Because I have 2 hydrogens, I'm multiplying atomic mass with 2. Totally, it's gonna be 2 atomic mass units. I repeat, the masses that I'm giving you here are rounded up values. In fact, it is 2.008, but then I have rounded it. Done? And what about oxygen? Oxygen's atomic mass is 16. And now I'm talking about oxygen molecule, which has 2 atoms of oxygen. So because I have 2 atoms of oxygen, I'm multiplying the atomic mass with 2 so that it becomes molecular mass, 32 atomic mass units. And now you try for ozone. One oxygen atom weighs 16 atomic mass units, and you're having 3 atoms over here, so it's gonna be 3 into 16, isn't it? And what is the value of 3 into 16? 48 atomic mass units, correct? Yes. So now what about, let's write this, 48 atomic mass units. And now you try and calculate the molar mass of N2. Each nitrogen, I corrected here. I hope you have noticed it. It's not 7. 7 is atomic number and 14 is atomic mass. Fine. So 1 nitrogen weighs 14 atomic mass units, and nitrogen molecule has 2 nitrogen atoms. So it's 2 into 14, which is equal to 28 atomic mass units. So in short, if I have to calculate molar mass, what am I doing? When we have to calculate molar mass, the common formula that we are using is the sum of atomic masses of all the elements present in the atom. Now you might ask me, ma'am, you're using multiplication. Yeah, you use sum and see, it's gonna be 1 plus 1. You use sum and see, 16 plus 16. 3 16s, which is nothing but 16 plus 16 plus 16, correct? So molar mass is nothing but sum of atomic masses of all the elements present in that particular molecule. Or you may also do this if you are talking about homoatomic molecules. Means what? Homoatomic molecules are those molecules which contain similar type of atoms. Then you don't even need to sum it, like, you know, take the atomic mass and multiply that with atomicity. That's what you have done here in this case. These are all homoatomic. Did you notice? So atomicity, by the way, what's atomicity? The subscript, the number of atoms present in each molecule is called atomicity, right? And now what if you are talking about heteroatomic molecules? What's hetero? Hetero in the sense dissimilar atom containing molecules. Like what? Like maybe say you're talking about CO2. CO2 is carbon dioxide. How do you calculate its molar mass? You can't use atomic mass into atomicity, right? Because you don't have similar type of atoms to do so. So you will be using this formula. You will be taking sum of atomic masses. Carbon's atomic mass plus 2 into oxygen atom's atomic mass, which is carbon's atomic mass is 12. Plus 2 oxygens is 2 into 16, which is nothing but 12 plus 32, which is nothing but 44. So 1 mole of carbon dioxide weighs how much? 44 atomic mass units. So this is how we calculate molar mass. Fine. I hope you are all understanding, whoever is listening to this video. But in case you're not understanding, you have any doubts, please do let me know in the comment section. Now let's take a fresh page and let's work out a little more on calculating molar mass. Fine. So we are taking both homoatomic, heteroatomic molecules here. So the first one is H2SO4. You are going to try to calculate all of this now. And the other one is HNO3. And the next one is NaOH. Please calculate the molar mass of these three molecules that you see on the screen. Pause the video, you do it, and then you cross verify your solution. Fine. So now if you have paused it and if you have tried it, now look at the solution. Fine. H2SO4. What all do I have? Firstly, this is heteroatomic. So I have to sum atomic masses of all the elements. How many atoms do I have? I have 2 hydrogens, 2 into hydrogen, plus I have 1 sulfur, 1 into sulfur, plus I have 4 oxygens, 4 into oxygen, right? So now, what is the atomic mass of hydrogen? It's 1. How do we know? We have to learn this chart that's written over here, this chart, right? And what is the atomic mass of sulfur? Sulfur is 32, fine. Plus 4 into oxygens, each oxygen is 16. So now simplify this, it is 2 plus 32 plus 4 16s, which is nothing but 64. And now all together H2SO4 is 98 atomic mass units. Fine. Did you get the same answer? If you have gotten the same answer, then that's good. You are doing it correctly. Then what is the mass of NH3? NH3, it's very simple because it's a simple molecule. You have 1 nitrogen plus 3 hydrogens, correct? So 1 nitrogen is 14 plus 3 hydrogens is how much? 3 grams. So 3 atomic mass units. Altogether 17 atomic mass units. What about NaOH? Now you say the answer. Have you got it correctly? Then let us see. Sodium is 23 and then oxygen is 16 and hydrogen is 1 atomic mass unit respectively. Which is gonna be 24 plus 16 and which altogether is how much? 40 atomic mass units. Did you get this correct? Then good. You have done it correctly. That means you have learnt it correctly. Fine. So guys, this is the second part of mole concept. Let us stop it here. Let's not, learn too much in one single video. I'll come up with mole concept part 3 for the calculations, like the calculations which are based on the balanced equations and all of that. But for today, this is all. We have learned what is atomic mass and I have given you a chart that you need to learn for atomic masses. And we have learned how to calculate molecular mass. I hope these videos are helping you. In case they are helping you, that's fine. But otherwise, if you need more help from me for chemistry, you can always ask me for the same in the comment section. Done? So I'll see you in one other video, guys. Until then, bye-bye.